Hello and welcome to this AQA Further Math Statistics video, the second in a series looking at errors in tests, and this time we're looking at type 1 errors for the continuous normal distribution. So a quick reminder of the definition of a type 1 error. A type 1 error is when we incorrectly reject the null hypothesis. So we find a false positive result at the end of our test, because based on the likelihood of events occurring, we decide to reject the null hypothesis, but in fact the null hypothesis in reality is in fact still true. For the normal distribution, that probability of rejecting the null hypothesis given that the null hypothesis is true is exactly the same as the significance level of the test. So we can say for continuous distributions that the probability of a type 1 error will always be equal to the significance level of the test. So looking at a very simple example here, and I'll give you a moment just to read through each portion of this example so you can take on board the information. We're talking about times x as our continuous random variable, and we know that the standard deviation is 4 minutes, and it's believed that the population mean time is 25 minutes. And in order to investigate this, we're going to take a random sample of 8 such items, and we are going to record the times that the varnish took to dry on each of those items, and then find the sample mean. And then a hypothesis test is to be carried out, and our significance level is given there at 5%, to investigate the belief that the mean is 25 minutes. So we're really talking about a scenario where our null hypothesis would be the mean is 25 minutes. And we've got two things to answer here. First of all, we have to explain, and notice it says in context of this question, the meaning of a type 1 error, and then we have to state the value of the probability of making the type 1 error. So looking again at the information we're given, we know the standard deviation is 4, we have a 5% significance level to work with, and we're testing whether mu equals 25 or not. And so in the context of this question, what would a type 1 error be? Well, a type 1 error would be to reject mu equals 25, reject that initial belief that the mean time for the varnish to dry was 25 minutes based on the sample data, when in fact the mean time for the varnish to dry is actually 25 minutes. So our sample happened to come out with perhaps some odd or slightly extreme results that led us, on the basis of our 5% level of significance, to think it was very unlikely that mu equals 25 was true, and it led us to reject the fact that the mean might equal 25 minutes, but in fact that actually is the case. And the second part of this says state the value of the probability of making a type 1 error for this test. So looking at the second demand here, state the value of the probability of making a type 1 error for this test. Well, the type 1 error is going to be equal to the significance level of the test, because we have a continuous distribution here, and therefore for this test carried out at the 5% level of significance, the probability of a type 1 error equals 0.05. So if we now look at a slightly more complicated example, and you might want to pause at the end of this and just spend some time reading through all the information you've been given. Well, we start off with a factory and a machine that fills boxes with rice, and the intention is that the boxes contain 1,000 grams of rice each. However, the machine that fills the boxes delivers an amount of rice x, which is a normally distributed random variable, and The known standard deviation is 45 grams and the machine is set up to deliver a mean of 1,000 grams into each box. However, we're told the machine may need resetting from time to time as parts wear out. And it's very common in production that the variability, the standard deviation of the way a machine behaves may be known, but the actual mean can be changed, and it may need resetting from time to time. So this machine's filling boxes with rice, and every hour from that hour's production, a random sample of 10 filled boxes of rice are obtained. The rice is emptied and the sample mean X bar amount of rice per box is calculated. And if our sample mean from the amount of rice contained within our random sample of 10 boxes is between 970 and 1030 grams, then the hour's production of boxes is deemed to be fine and can be sent out to the customer. If not, then that hour's production is rejected and it cannot be sent out to the customer, and the machine settings will need to be checked because possibly something's gone a bit wrong and it's either under or over delivering the amount of rice per box. So the demands here are, first of all, find the probability, assuming the machine settings are correct, that an hour's production is rejected. And then B, explain how the probability we found in Part A connects to a Type 1 error. So there's a summary of the relevant information that we need there. And we need to find the probability, and note it says assuming the machine settings here are correct. So that gives us some information about the mean and standard deviation, that an hour's production of filled boxes is rejected. So first of all, going with the information that we've been given on this line here about what our sample mean, what sort of values we expect so that we would find our production acceptable, we are going to need the probability that our sample mean from those 10 boxes taken out of an hour's production lies between 970 and 1030 grams, given that the machine settings are fine, that the machine is set to deliver with a mean of 1,000, and that the standard deviation, as we're told, is 45. So bearing in mind that we have been asked to find the probability that the hour's production is rejected, if you think about the information we were given about the probability an hour's production is accepted, which is here, our sample mean amount of rice per box from our 10 boxes is between 970 and 1030, given that the machine is set correctly. This is quite a simple probability to find directly from the calculator, but you do need to recall the distribution of X bar, which, bearing in mind X is normally distributed, X bar would also be normally distributed mean mu, the same as the population mean, but remember that the variability is reduced, the variance is sigma squared divided by n, so the standard deviation for X bar would be 45 divided by root 10, and this is the standard deviation you must use when finding this probability here. So working that out directly from the calculator, and check you're okay with that, you should get 0.964, and so the probability that an hour's production is rejected is simply 1 minus that probability of acceptance, and that should give you 0.036. So we've worked that out. Part B says, explain how the probability found in Part A connects to a Type 1 error. Well, the probability found is equivalent to the probability of making a Type 1 error. And if you have a look at the test, you can see it's set up in the context of a process that happens in a factory. So people who are working in the factory are not expected to understand hypothesis testing. So they are simply given some rules in terms of when they accept and when they reject an hour's production. And they were told that they had to accept if the mean was between 970 and 1030 grams. Otherwise they're going to reject. And we're actually able to work from that information, find a probability that an hour's production is rejected even when the machine is set correctly, and that's the equivalent probability to the probability of making a type 1 error in this scenario. And that's the end of this video.